everybody. In this video, I want to discuss geometric variables, and I want to talk about an application of geometric variables. So let's get to it. Suppose we have a spinner for a board game that will land on green 30% of the time, red 20% of the time, and blue 50% of the time. Each spin is independent of each other. What is the probability that we spin to our first green on the fourth spin? So obviously I am talking about a geometric variable in this video, but how do we know it's a geometric variable? Well, it's all about the keywords. So when we get to the question here, it says, what is the probability that we spin our first green on the fourth spin? When we're looking at geometric variables, we're all about our first success, So that's how I know this is a geometric situation. So let's get to it in this problem. So what we need to start off with is defining our variable x. Define what in the world are we even looking for? So we are looking for our spinner landing on green, That's what we're looking at. That is the outcome we want. Now, as I previously talked about, we know this variable x is geometric. So I defined what is x, spinner landing on green, and I'm already going to say, hey, this variable x is also geometric, but I need to figure out what is the probability of success here. So before we dive too heavy into this problem and know I can do a full geometric situation, we need to talk about what is success, what is failure, does that probability of success stay the same, and are things independent? So suppose we have a spinner for a board game that we land on 30% of the time is green, 20% red, and 50% blue. Success in this situation would be landing on green. Even though there's three situations here, green, red, and blue, success is green. Therefore, failure would just be anything but green. That means red or blue. So our probability of success is 30% or 0.3. Now, I hope when I spin this spinner, the chance I land on green is 30%. I hope that stays the same throughout, so we have a constant probability of success. And then our last line, each spin is independent of each other. So we have a Bernoulli trial, therefore we now know I have a geometric situation. So I've defined x, I've said, hey, x is a geometric situation. What I want to know is what is the probability that we spin our first green on the fourth spin? So let's get some notation here. I'm trying to find the probability that the spinner lands on green on the fourth spin. So our first green on the fourth spin. Probability that x equals 4. So what we're going to do in the calculator, and I've shown this in class before, we are going to use our geometric, since we are geometric, either a PDF or a CDF. So remember, to get to geometrics, PDF, CDF, you do second distributions, and we want to get to the bottom. There's our geometric PDF and CDF. Since I'm trying to find the probability that x equals 4, that is a PDF. So we just need to enter in our information. Probability of success is 0.3. The x value is 4. And what I'm going to do is I'm going to write down this on my paper as well as my answer of 0.1029. That's going to allow me to show and illustrate my work that I know what's going on here. So we did a Geomet PDF 0.3 comma 4. And when I hit enter on my calculator, I got 0.1029, meaning there is a 10.29% chance my first green, I almost spelled that wrong, first green on the fourth spin. Okay, so important there is defining what x is, defining that, hey, this variable x is geometric, and then yes, go and fetch in the calculator geometric PDF when we're doing probably that x equals 4. If I was doing x is less than or equal to 4, we'd look at a CDF there. Write out the function, write down your answer. Context is nice. Another quick example here for a refresher for you. What is the probability that it takes more than 3 spins to get our, oh, there it is again, first green? So the situation has not changed. We're still talking about x being a spinner landing on green, and we still know, since we're trying our first green still, x is still geometric. So I do not need to rewrite these two lines down here because that information is staying the same. Now, what we're trying to find the probability of, that is changing, so I'm going to write that new notation. So what is the probability that it takes more than 3 spins to get our first green? Well, x represents our spinner landing on green, and to represent the probability that it takes more than 3 spins to get our first green. So more than 3. That is our inequality there. Now here's the tough part. I do have functions in my calculator. Geometric PDF, that's for when we're doing an x equals. But the CDF function, yes, it is used for inequalities, but the CDF counts down. So when I say I want the probability that x is greater than 3, that means I want numbers like what's the probability I get it on the 4th time, the 5th time, the 6th, 7th, etc., etc. That is counting up. So what I'm going to have to use here is I'm going to have to use the complement. Okay, let's find the opposite of this. The opposite of asking what's probably that my first spin will happen in more than 3 spins is what's probably that my first spin happens in 3 or less. Okay, this is something I can calculate with a CDF because it will count down from 3 for me. And I'll find this answer, subtract it from 1, and what's left should give me the probability that x is greater than 3. Okay, x is greater than 3. So I'm going to do a GeoMet, I already know, a GeoMet CDF. Let's take a look at this in the calculator. Second distributions, scrolled on down, GeoMet CDF. We put in our success is 0.3. Our x value is going to be 3 as well. And let's hit enter. So we're talking 0.3 comma 3. I get 0.657. So if I take 1 minus 0.657, I should be left with my final answer here, which is 0.343, meaning there is a 34.3% chance that it takes more than 3 spins for my first green. Okay, a geometric CDF there, along with the complements. A little bit complicated there. So what I've done here is just a quick overview of how do we do geometric problems with our calculators. Remember, if we're doing an x equals, it's PDF. If you're doing an inequality, you're going to be using some form of the CDF. Just pay attention to, hey, do we want to count down or do we want to count up? Only other thing that I want to highlight is do make sure you define your variables and communicate that, hey, I understand this is a geometric problem. So that was a geometric variables application.